Alright guys, in this video, we're going to be doing the preparation for your paper 3 for chemistry. Ujian Amali Sains, paper 3 for chemistry. I've already done one on bio. If you want to see, on physics. If you want to see that, then I'll leave the link in the description below. I'm also going to be doing one on bio. Once that's completed, the link will be in the description below. All right. Okay, so the topic that I've chosen, the sample topic that I've chosen here is on the difference in properties between ionic compounds and covalent compounds. Okay, so let's just go back to the theory for a little bit. So the theory here for the difference in properties between ionic and covalent compounds, actually there are three experiments. There are actually three experiments. So one is on the difference in electrical conductivity. Okay, another one is difference in solubility, as I'm going to discuss in this video. And then we have another one on a difference in the melting and boiling point. Right? So please do go through the rest as well. Right? Please do go through the rest. By the way, class, this is my notes for my actual class, my classes. You can join my classes if you'd like on mrrueltuition.com. You can just directly join. No need to contact anybody. It's a very seamless process. Okay. I have SPM preparation classes as well, right up to your paper. So if you want to join, just go to mrrueltuition.com. Okay. So now here, I want to stress, please don't take this as your magic card. Okay, don't use this as a prediction. Don't rely solely on this. Please be prepared to answer any topic. Okay, don't panic if the topic doesn't come out. If something else come out, it doesn't matter, because from the techniques that I'm going to teach you in this video, you will be able to answer whatever topic that comes up. Don't worry, you may not be able to get all of the marks, but definitely you can get at least half, even though you don't know the experiment. Don't worry. Okay, and don't overly rely on this. Please learn the techniques rather than just memorizing the content here. Okay, let's get into it. So look at the sample question here. You are given two samples of white solids. We have substance X and Y, substance X and substance Y. You are required to conduct an experiment to investigate. Now, if you get a question like this, then you're very fortunate, right? The better question would be investigate the relationship between. But here, there's no relationship between. Here is just you want to investigate the solubility of two types of compounds. Okay. The first thing you need to do after reading the question is to determine your MV and your RV, manipulated variable, responding variable. That's the first thing we must determine. So after investigate, usually that's where the MV and RV is. So here we have two things, solubility and then two types of compounds. So which is the MV and which is the RV? You have to think to yourself, which one am I setting, or which one am I differentiating at the beginning of the experiment? Or which one am I fixing at, which one am I setting at the beginning of the experiment? Which one am I changing at the beginning of the experiment? And which is the one where I am collecting data at the end of the experiment? Okay, so the one that we are fixing and setting, the one that we are changing at the beginning of the experiment, not fixing it, the one that we are changing at the beginning of the experiment or differentiating at the beginning of the experiment, that is the manipulated variable. What we change at the beginning, the effect of the change at the end of the experiment, the data that we collect, that is your RV. Simple as that. So in this case, what are we changing in the beginning? We are changing the types of compounds. And what are we collecting at the end? What data are we collecting? It is the solubility. So that is your RV. Okay, of course, you can't just write solubility here. It must be a bit more complete. Later, I'll show you the sample answer, right? So look at the apparatus and material provided. So we have test tubes, 5 grams of X, 5 grams of Y, and then we have distilled water and acetone. So you already know this is about solubility. So do you know what is the role of acetone then? So when we do the topic of solubility, we don't just do solubility in water. We also do solubility in organic solvent. And acetone here acts as the organic solvent. Now, acetone class is also propanone. It's the same thing. It's the same compound. Okay, it's a very common organic solvent. All right. Okay, so here we got solubility in distilled water and organic solvent. So you have to pick it out from the apparatus and materials. All right. Okay. So let's go on to write the procedure for the experiment. So there are two types of questions. One is guided, one is unguided. Guided, you are given the procedure. Unguided, you need to write the procedure. When you write procedure, there's two formats usually. One is only according to methods of handling variable and the precautionary steps. In chemistry, not so common. In chemistry, the more common procedure would be the full procedure. That means here you don't see, they didn't say in your procedure should include methods of handling variable and precautionary steps. We don't have that here. So you give the full procedure. Now, how to write a full procedure is very simple, class. This is the same technique you can use for all of your paper 3. Okay, physics, chemistry, bio. Use the frame. Frame has 4 components. The first component will be, the first thing that we do is to measure and prepare. Measure and prepare everything, right? After you've measured and prepared everything, then you can start the experiment. Then you start the experiment. After you started the experiment, what's next? Once you've begun the experiment, then you start collecting data, isn't it? Data collection. So this is where we observe and record data. Once you've collected all the data, then if we have manipulated variable sometimes requires you to repeat the entire experiment by changing the manipulated variable. So repeat, finish. You just need this frame, these 4 components, and you can write any procedure. As long as it contains all the 4 components, your procedure will be complete. Okay, your procedure will be complete. Now, here, measure and prepare. What's helpful is if you know the diagram. From the diagram, you can easily tell what you need to prepare, because everything in the apparatus setup diagram, everything in the apparatus setup diagram is already prepared. So you just have to refer to it. Okay. Now, so also please be prepared to draw the diagrams. Of course, here there's not much of a diagram. Let me show you the theory again. So here is just solubility. So literally, you're just going to put the solvent and put the substance into 2 different test tubes. That's about it. And what's good about this is that's also what you write. That's all. Put the substance in a test tube, put water. Done. Okay, so of course not in those exact words. Yeah, so let's look at the measure and prepare step. So first will be, we just put 5 grams of substance X into a test tube. Put 5 grams into a test tube. Now, sometimes if they give you labels, if they provide labels for you, then your first step can be label 2 test tubes as X and Y. Okay, and then put 5 grams of substance X into test tube X, for example. Okay, that could be it. If you are given labels, you can do that. Okay, now once you put the substance into the test tube, that's all the preparation you need. Next will be to start the experiment. How do you start the experiment? Here we want to study the solubility. We want to study the solubility of the 2 different compounds. How do you start an experiment to study solubility? Why? We add solvent, of course, isn't it? Just add the solvent, you started the solubility, right? You can now study solubility. So what is how to start the experiment? So we add 5 cm cube. Take note of the volume. Yeah, 5 cm cube of distilled water into the test tube and shake. This is important. You need to shake it to help it to dissolve. Right? Okay, and that's it. That's it. We've already started the experiment. There's nothing left to do but to observe. So what are we going to observe here? What are we looking for? What is the data that we want to collect? Whether it's soluble or not. Right? So observe and record the solubility in water. So far, we've only done water, right? But don't forget, we also have to study the solubility in organic solvent, in acetone. So what do? This is where we start our repetition. So first, you need to repeat steps 1, 2, 3. Follow your number of steps. Yeah, don't just do 1, 2, 3. Depends on what you have written. So here I have 3 steps. So I'm going to say, repeat steps 1, 2, 3 by replacing the distilled water with acetone. Now, even when we replace the distilled water with acetone, in this case, we are only doing substance X still, even after we've repeated. We did once with distilled water, you repeated it with acetone. So we only have covered substance X so far. So therefore, we need to repeat the entire thing, steps 1 to 4. We need to repeat it again, but this time we replace substance X with substance Y. Okay, now it is complete. Done. Okay, use the frame. It's very simple. It's very simple. Okay, let's go on to tabulate the observation. So when you are doing your table, again class, here, we have to sort out the variables first. So let's sort out the variables first. What was the manipulated variable again? We are going to investigate the solubility of two types of compounds. So what is the manipulated variable? Here it is the type of compound, right? It's the type of compound. This is what we are manipulating. And then what is the responding variable? At the end, what do we want to see? The solubility. Solubility in water and organic solvent. Now, what needs to be fixed in this experiment? So this is an experiment to study solubility. So therefore, all other factors that can affect solubility must be constant. It cannot be more likely to soluble in one of the experiments. It must have the same likelihood to be soluble other than due to the nature of the substance itself. So what are the factors that can affect solubility? There are 3. Mass of compound. Okay, the higher the mass of compound you use, the harder it will be to dissolve, right? Volume of solvent, the more solvent you use, of course, the easier it will be to dissolve. And then the temperature, the higher the temperature, the higher the solubility. So all this must be fixed for both the ionic compound and the covalent compound for us to make a fair comparison. Right? Okay, and now we can go on to tabulation of data. So the basic table consists of MV in the first column, manipulated variable first column, second column, responding variable. This is the basic table. However, if there's any other data that you collect from the experiment, anything that you collect from the experiment, any other values that you measure or anything else that you observe, everything must be tabulated, right? So we start with here, MV, manipulated variable. What is the manipulated variable? Type of compound, isn't it? Okay, so here will be type of compound. What is the responding variable? Solubility, right? Solubility in water and in organic solvent. So that will be here. But of course, solubility, we are going to separate it, right? So this is what the table looks like. Okay, type of compound MV, this is the RV, solubility, water, distilled water, and acetone separately. Okay. So after observation, then we come to inference. State the inference for your observation. So this inference class is not to be confused with the inference for physics. The inference for physics is unique. It is not an inference based on observation like this. They won't ask for inference based on observation. They will just say state the inference for the experiment. That's different. In chemistry and biology, we don't have such a thing. Okay, there has never been such a thing for chemistry and bio up till now. So state the inference for your observation. This is inference for observation. So what is an inference for observation? Why? That's it. Why is the observation that way? That's all. Right? So I'm going to give you some sample answers, some sample data here. Of course, this depends on your own experiment, but I'm going to give you some sample data so that we can answer the inference part. So let's say substance X was soluble in water and insoluble in acetone. So what is the inference for this? Why? Why is substance X soluble in water but insoluble in acetone? So what kind of compound behaves this way? What kind of compound is soluble in water but insoluble in acetone? That would be ionic compounds, isn't it? Ionic compounds are normally soluble in water and insoluble in acetone. Of course, there are exceptions, but generally, right? So Why is substance X soluble in water but insoluble in acetone? Simply because substance X is an ionic compound. Done. That's about it. That's your inference. Okay. Now, what about substance Y? Substance Y is insoluble in distilled water and soluble in acetone. Why? Because what kind of substance behaves this way? What type of compound behaves this way? What type of compound is insoluble in distilled water but soluble in acetone? Covalent compound. So why is it behaving this way? Because substance Y is a covalent compound. Okay. All right. So that would be the basic inference. If it's just 1 mark. Okay. It's a basic inference. Substance X is an ionic compound. Okay. You don't have to say made up of ions, ionic compound. And then substance Y is a covalent compound. Done. You don't have to say made up of molecules. Now, the reason I added that is in case it's more than 1 mark and you need to explain further, just in case. If it's just 1 mark, or in this case, it could be just 2 marks because you're explaining for 2 substances. Don't add anything else. Don't. In case you need to add more, the explanation for this, the further description for this would be water molecules help to overcome the electrostatic force of attraction between ions. Now, let's go back to theory a little bit, just for a little bit. So water, if you remember class, water is made up of 2 hydrogen atoms and 1 oxygen atom. Now, oxygen atom is much more electronegative than hydrogen atom. Okay, that means oxygen has a much higher tendency to receive electrons. It's better at pulling electrons towards itself. Now, in this covalent bond, there's 1 pair of electrons being shared between oxygen and hydrogen. However, because oxygen has a greater pull of electrons, oxygen will pull these electrons that are being shared more towards itself. Hydrogen will be, the electrons will be a bit further from hydrogen. So what happens here is this creates a partial charge. So oxygen will have a partial negative charge and hydrogen will have a partial positive charge. The same thing happens here, by the way. Right? Because of the difference in electronegativity. So now that we have partial negative charge here, because oxygen is so good at pulling electrons, all the electrons are nearer towards the oxygen atom, but further away from the hydrogen atom. So we have a partial negative and partial positive charge. This is not a complete charge. It's not a complete charge. It's not an ion. Okay, because electrons are not completely transferred. No. Okay, so it's a partial charge. Now, this positive part, partial positive part, is able to form bonds with a negative ion, isn't it? And then this negative part will be able to form bonds with a positive ion. So this is why water is able to overcome the electrostatic force of attraction between the ions. Okay. So I'm just going to give you the full explanation. You don't have to write this in your answer. Okay. I just want to give you the full explanation here. So full answer, the answer would just be this. Okay. But the full explanation now, organic solvents are made up of molecules which are neutral. Okay. And they do not carry any charge. So organic solvents are neutral. They don't carry charge and they're not polar. This is what we call polarity of water. Water is polar. It has a partial negative and partial positive charge, right? Okay. So organic solvents, they are neutral. They don't have any charge. They're not polar. And so they cannot overcome the electrostatic forces between the ions. Okay. So when the water molecule overcomes the electrostatic force of attraction, it is able to break down the lattice structure of the solid compound. Remember the lattice structure? So the lattice structure is simply this class. The lattice structure is a positive, negative. The arrangement of ions like this. This is the lattice structure. Okay, the arrangement of ions in space. Okay, so it is able to break down this lattice structure because it is able to interact with the, it's able to form a force of attraction with the ions and pull it away, pull it apart. Okay. So for covalent compounds, what's the story? The covalent compounds, organic solvents can still form van der Waals force of attraction with the covalent molecules. Okay, so covalent molecules themselves in solid form, covalent molecules themselves, they are bonded together by van der Waals force of attraction. Now, the organic solvent itself is also a molecule. Okay, this is the solvent. So the solvent molecules are able to form van der Waals force of attraction with the solid molecules. And this is strong enough to break the van der Waals force of attraction here. So yes, it can dissolve in organic solvent. That's the story. Okay, but again, class, I'm just teaching you the theory so you understand this. For the inference answer is only this. Substance Y is a covalent compound. Okay, now let's go to the next part, hypothesis. So the usual format for hypothesis would be the greater the MV, or greater or lesser the MV, the greater, lesser, or RV. Or you use what I like to advise my students for grammatical reasons is when MV increases or decreases, RV increases or decreases. So you can use this format. However, if you have a variable that does not have a quantity, for example, type of compound, you can't say the greater the type of compound or the lesser the type of compound. You can't say when type of compound increases or decreases. Okay, even the RV here is not quantifiable. Solubility in water, you can't say actually this one you can, greater the solubility, but that's a different story because here is only soluble or not. Okay, so anyway, if you have variables, okay, your MV or your RV, either one is enough. If either one is not quantifiable, doesn't have a quantity, how do we frame the hypothesis? So the hypothesis here in this case would just be a statement outlining the conclusion of the experiment. What was this experiment about? Actually, the statement would answer the problem statement. You remember the problem statement? Problem statement is a question, right? In the form of question. So the problem statement for this one would be, okay, what is the difference in properties? What is the difference in properties between ionic compound and covalent compound? Okay, this is a general problem statement, so this is a poor choice. Yeah, but the problem statement is something like this. What is the difference? So your hypothesis and your conclusion must answer this question. What is the difference? Okay, so in our case, specifically for solubility here, okay, specifically for solubility, how do we answer? What is the conclusion? What have we concluded based on our experiment? We are trying to study the solubility of ionic and covalent compound in water and organic solvent. So the answer to that question is ionic compound is soluble in water but not organic solvent, whereas covalent compound is soluble in organic solvent but not in water. That is our conclusion. Okay, and that would be the hypothesis. So the hypothesis here would be this. All right. Okay, now let's get on to the last bit, which is operational definition. Now, operational definition for chemistry is never a problem. It's very clear. It's very clear cut. Okay, many mark schemes all point to the same thing. What is done, what is observed. Very clear. It's a bit different from bio. The format is different from bio. Don't use this format for bio. Okay, I will produce a video for bio, and when it's done, the link will be in the description below. Don't use this for bio. Okay, so what is done, what is observed? Now, what is done, okay, when you want to choose what is done, it is actually based on what is observed. So it's always easier if we start with what is observed. Then you trace back and see what did you do to get that observation. So observation here, when we say what is observed, it must be data collected. It must be practical. It cannot be theoretical, right? For example, you cannot say rate, let's say this is an experiment on rate of reaction. You cannot say rate of reaction is the what is observed. No, we did not observe that. We did not observe or measure that. No. Okay. What is observed must be directly the data that you collect at the end. So what data did we collect here? What did we observe? It was the solubility, isn't it? So since we are doing operational definition for the covalent compound, you only choose the covalent compound. Okay, we only choose the covalent compound. So here, what is the observation for the covalent compound in our particular experiment is substance Y, isn't it? Do use specific details in your answer. Don't give general answers. So what is observed? Substance Y dissolves in acetone, but not in water. This is what we observe for the covalent compound, isn't it? This is what we observed. Substance Y dissolves in acetone, but not in water. So this is what is observed. Now we can trace back to what is done. What did we do in order to obtain this observation? What is done? So we simply added substance Y to distill water and acetone separately, isn't it? This is what we did. Substance Y is added to distill water and acetone separately. After we added them separately, then the observation was substance Y dissolved in acetone, but it didn't dissolve in water. So this is what we mean by what is done and what is observed. So how do you tie them together in the answer? This is very simple. Very simple. You start with when. When we did what we did, comma, we observe what we observed. When we did what we did, comma, we observe what we observed. So when we did what? When substance Y is added into distilled water and acetone separately, comma, we observe what? We observe that substance Y dissolves in acetone, but not in water. Done. That's it. All right, that's it. All right, guys. So again, I have already done a video for the physics paper 3. It's already in the description. And I'm going to do one on the bio. I will also put that in the description when it's done. Don't rely solely on this. Please learn the techniques from here and apply it to your own paper. Don't worry. You will be able to do it. Don't worry. Okay. It's not a difficult task. Even if you don't know what the experiment is, you can still tackle things like your variables. From the question, you can try to figure out the variables. Once you have the variables, you can still answer hypotheses. You can still answer, okay, what else can we answer? Yeah, hypothesis. If they ask for conclusion, you can give your conclusion. Okay, you can do. All right, and then you can just collect the data. If it's guided and they give a procedure, just follow the data. Just collect the data. Right, you'll get marks for all that. So don't worry. Okay, is there a probability that graph will come out? Yes, of course. Yes, of course, there's a probability that graph will come out. Please make sure you identify whether it's there or not. If a graph is there, you need a lot more time. So you need to manage your time well. Okay, if there's no graph, no problem. But if there's a graph, you need to allocate time to draw graph. Right? Okay, guys. So all the best to you. I really hope that you do very well in your paper.